Hello friends, this is Vikram from .NET for All, and today we are going to solve a very interesting problem which is known as unique paths. This is problem number 62 from Leetcode, and the problem says that suppose there is a matrix of m rows and n columns, and there is a robot which is present on the top left hand side corner of the matrix, and there is a star which is present on the bottom right hand side corner of the matrix, and we need to find out the number of ways the robot can reach this star. So this is quite a unique problem, and it could be solved with the help of recursive programming as well as with the help of iterative way of solving this kind of problem. And so basically let's try to understand the concept behind this problem. So what it tries to say is like suppose there is a robot. So basically the robot is here, and this is the initial point and this is the final point. So in how many ways the robot can reach this final point? So one way would be this one in this specific example, and other way would be this one, and the third way would be this one. And the provided condition is that robot can only move right, left, up or down. It can't move diagonally. So suppose there is a matrix with only one row, and there are some columns, number of columns, but the number of row is only one. So what is the number of ways the robot can travel from this initial point to final point? That would be only one way. And again, suppose there is a matrix which has only one column. So what are the number of ways a robot can reach from this starting point to this final point? There is only one way. So now coming to let's expand the example. So now we want our robot to travel from this point to this point. So the number of ways the robot can reach this specific point is the number of ways the robot can reach this point, and the number of ways the robot can reach this point. So suppose number of ways the robot can reach this point is 1, and again the number of ways the robot can reach this point is 1. So it would be addition of these 2 points. So the number of ways the robot can reach at this specific point is 2. So one way would be this one, and the other way would be this one. Now let's expand example bit more. So here in this specific example we have 2 rows and 3 columns. So what is the number of ways robot can reach this point? So it would be number of number of ways robot can reach this point, and number of ways robot can reach this point. So here what is the number of ways robot can reach? It would be 1. And here how much it would be? So it would be number of ways a robot can reach at this point, and number of ways robot can reach point. So here it would be 1, again here it would be 1. So for this specific position, number of ways robot can reach at this position is 2. So the total for this specific position would be 3. So I hope you are you are able to understand what we are doing here. So basically what we are doing here is, suppose our method is number of ways and our input is n and m, rows and column for that specific grid. So if n is equal to 1 or m is equal to 1, we have to return 1. So suppose there is only, as I mentioned in this case, if there are number of rows and number of columns are only one, then in that case there would be only one way to reach uh, that specific endpoint of that matrix. But now suppose there are more than one, so suppose this is the matrix. What did we do actually to reach at this point? So what we did is we summed up the number of ways a robot can reach at this position and this position. So it would be a recursive way to find the solution. So we would be calling the same method to, like, I would name this method as ways, to just have a short name. So it would be ways n-1 plus ways n-1 m. So I would m plus n m-1. So this would be the simple solution, but there is a problem with this solution. So suppose user wants to find the position of this one, so he has to find the number of ways robot can reach here and robot can reach here. Again he has to find the number of ways he can reach here and he can reach at this position. So we are kind of doing some repetitive work again and again in this solution. So how to mitigate? We would be keeping the basically memory. We would be keeping the results in the memory so that we don't have to do repetitive work. What is the way how we can solve that without doing the repetitive work? So it would be number of ways n and m. So initially what we would be doing, for I equal to 0, I is less than m. So before that we would be keeping a integer array. I would say it as dep. This would be used to store the the result of the, basically while we would be creating from top to bottom, it would be storing the results of the calculation which we have already done. So now we have this array. So now we would be for I equal to 0, I less than n, I plus 1. So if so basically for each row, the first column would be set as 1. So like suppose this is the matrix, and in this case for each row, all of these, there is only one way which the robot can reach at any of these cells, if this is only a matrix of one column. And again for each column, again for each column we would be setting it as 1. So again suppose for these cells we would be setting the values as 1. Now we would be having two loops as equal to, first loop will be going with each row. Row is n in my case, and for each column j. We would be having a dependency of j. It would be dependency of I minus 1 j plus dependency of I j minus 1. So we are basically building a data structure or memory from the top to bottom way of approach, and the return would be, finally we would be getting our result in the last, basically m minus 1 and n minus 1. So last cell of our multidimensional array would be having the result of this dynamic programming solution. So this is the way how to solve this problem and how to tackle that. I hope you like the way. If you like, please do subscribe and like the video. Thank you.